Welcome to Local is Lekker, where we look for local businesses with a lekker story. As you can see, today I am in Umhlanga Ridge, which has seen an explosion of property development over the last couple of years. And most of these buildings have got one thing in common: they've got a massive foundation. And in today's video we are going to visit John Oliver from Megapile, who's responsible for creating a foundation for these sort of buildings. And I'm very excited to bring you this story.
I think we all have some very special little things in life that give us great pleasure. And one of the things that I really get great pleasure out of is hearing this machine idling with his flaps, his exhaust flaps flapping. It's such a unique sound, you don't hear it anywhere else. And to have him running and knowing that he's working, that sounds very special to me.
I'm John Oliver from Megapile. We started in 2004 in the piling industry, part of the construction industry where we do piling and geotechnical work. So if you see any buildings, for those guys that don't understand or know what piling is specifically, all the buildings that you see in ground conditions that are not suitable, we go along and we install piles in the ground. So we drill into the ground, put concrete into the ground and reinforcing, and then the building gets built on top of those piles. That's just to basically secure the foundation and make sure there's no settlement in the building. We started with our first crawler crane, which was a drag line set up in one of the rivers, pulling sand out of the river to sell sand. And the thing was broken, and we got that crane, refurbished it and set it up as a piling rig. And that's where we started with getting into the bigger market on the piling. As we developed the company and as we grew, we bought a second crawler crane, the RB38. We bought one of those and then a second one of those, and started establishing the fleet of big rigs to compete on the bigger market. And then eventually we then converted and went into the more sophisticated and the newer type of piling rig, which was the computerized hydraulic piling rigs. We went to Bauer in Germany. They are the Rolls-Royce of piling rigs in the world. And we started with bringing in the first Bauer into South Africa, RG22, which is a really big machine still running today. And but in that process, we had to get rid. There was no more use for the old crawler cranes, and they became redundant. So when we got to the point of having to cut them up and scrap them, we wanted to keep something from these old cranes to just remember and to be able to show people how we actually started piling and what we used to do. And these are parts of C1, our original crane. Just the tags, the old brass tags out of the crane, just explaining the controls, the history of the crane, an RB, Ruston Bucyrus from the UK. And this is the control panel. So it was a combination of air and mechanical operating. So your air levers engaged and disengaged, pneumatically engaged and disengaged brake bands, which then turned big wheels. Those big wheels ultimately converted and turned these big wheels and these chains to drive the crane. So this would drive the tracks. This would pick the boom up and down. So it was all a combination of pneumatic and mechanical. And it was hard work. The guys used to work very hard pushing and pulling levers to make this crane do its thing. They weren't that great. Ultimately, when the new hydraulic cranes arrived and all computerized, it's made a very, very big difference. And these guys just eventually got outperformed massively. And that's why we then did that conversion and eventually got the 3 Bauers. Which really just improved our capacity immensely. But nice to see the old guys and what we used to do with the old cranes. And this is an auger. So this is a typical auger that we drill into the ground. It has the tungsten tips on it. The bit setup is you change that for different ground conditions. So there's a whole variety of designs for the bits. This is just one typical bit that we use, and depending on whether you're drilling in sand, drilling into rock, what you're doing, it would decide on the design of those tips. And those bits are critical to your effectiveness or your efficiencies in the ground. If you use the wrong bit in the wrong ground conditions, especially when you get harder ground conditions in rock, you just get absolutely zero penetration. It just doesn't work. So it's all part of the process of learning and developing. These augers, we manufacture them ourselves in our yard. From scratch. We get the pipe, we get the discs, we then pull the discs, weld the discs, and manufacture all our own augers and build all our augers from a 250 diameter auger, which is the smallest one we use, up to 1.2 meter diameter augers, which are the big diameters. And those are really big piles. But that whole function of manufacturing those, they're very, very expensive to import. A very specialized technique in getting these augers right when you're trying to manufacture them. You've got to get your pitch correct between the blades. That's got to be, and relative to the diameter, that's all got to be correct. And so there's very specific calculations and formulas that you need to know to actually cut the discs correctly, so that when you do weld them and pull them, they actually land up stopping at the right position on the center pipe. And then we do that whole, we have a whole fabrication set up in our yard. We weld them together complete, do the whole thing. So yeah, that's part of our operation in the yard of what we do. It's saved us a lot over the years, and obviously then also maintenance. We maintain these. You've got basically an edge that gets worn down. So there's hard facing on those things, and they get regular refurbishment in the yard. To make sure that they're working properly. So yeah, part of our work that we do as Mega Pile is piling and geotechnical work, and this forms the lateral support portion of that type of scope that we cover. We do a lot of lateral support. These type of walls with soil nails, rock bolts, shotcrete, gunouting, as well as contiguous walls. A little bit of a different system where we install piles up front, and then as we drop, they then support the ground, and we do those with a combination of soil nails as well. A lot of it all around Umhlanga area on the ridge. Some basements as deep as 13.5 meters, 14 meters deep vertical support to create all the basements on the big buildings in Umhlanga. So this is one of the sites called Arbor Crest, just near Manzimtoti. The original scope of the works here was to do dry stack walling, and when they were busy in this area, the wall started collapsing and they couldn't install dry stack blocks. So it was a bit of an emergency job. Engineers got hold of us and asked us to come and have a look and see if we could provide a solution to retain this boundary wall when they excavated. So we did a design and construct contract here with a combination of soil nails and shotcrete to stabilize this embankment. The retained height starts here at about 1.5 meters, and at the highest point at the top is over 5.5 meters high. And obviously they were very concerned because of the dune sands. These are collapsible dune sands, and they were very concerned with the safety of the people working, and also potentially the wall falling down. So we've had to start at the top. This was a very big embankment, and we started right from the top, installing rows of nails and shotcrete in very small increments to keep the stability in place while we did the lateral support. The guys have reached the bottom. They're at the bottom now. You can see the drains coming through. So those drains there are to make sure that there's no water ingress from behind the wall. One of the biggest problems with lateral support is groundwater build-up behind the wall. Puts a lot of pressure on it. So there's a series of drains all the way along here that drain behind the wall. So we're almost at the bottom. We got one more drop to go at the top, and Monday, Tuesday next week we'll have the job 100% complete. This is a soil nail sticking out. These nails are generally 3 meters to 6 meters on this particular contract. So that nail is installed in the ground, it's grouted, and that is the support. We put a plate, we put bolts on, and that becomes part of the structure with this mesh. And so this wall that's supporting the ground is actually supported by those nails which are anchored back into the ground and hold the whole wall in place. The marker there is for monitoring. When we do lateral support, any lateral support that we do, you'll see the markers all the way along the wall. So as we're installing, we start at the top and we'll do a survey of the wall and get its exact position. And as we're dropping and as we're building this wall, as we come down, we keep taking surveys of the position to see that there's no movement. So this is our indicator. If those started moving, there would be a problem with the design of the wall. We'd have to stop and reassess. But that's always done on every lateral support job so that we monitor that the wall's staying still. So that's what you see there. So for this particular contract, these are the soil nails that we're putting in. It's basically a thread bar, TB500. There's different categories, but this is a thread bar. A high tensile strength bar, steel bar that we use to put in. It's threaded so we can put a nut on the end and the plate to secure it once it's in the ground. What we do is, these are the spacers. These keep or centralizers, they keep the bar in the middle of the hole when we insert it once it's been grouted. What we have found is a lot of these items, you can buy these off the shelf. Not quite the same shape or the same design as ours. So what we've done is we've, over the years, developed our own spacers to make sure that we can install the bar a lot easier. It works very, very well. Just by trial and error, we've developed them. And we also, it's a lot cheaper, a lot more cost effective to design our own spacer bars and use those. So the guys manufacture this in our yard, normal standard tube. The flat bars, we take the flat bars, we bend them to a specific, on a specific jig, get those bent up, weld them all together, and then we galvanize them and we use these on the bars as centralizers. All of the little bits and pieces that we save, doing it all ourselves, I think it all just adds up. You can see the hole here. This is the holes that have been drilled before they get grouted. So we'll grout those, install the nail into that, and that will then sit inside there, and that will be your anchor. Those nails are designed at this job 1.5 centers. So every 1.5 horizontally, 1.5 meters, there's a nail, and every 1.25 meters vertically, there's a nail that's installed up the full face of the wall. So this wall that you see now, you don't see it, but it's got nails every 1.5 by 1.25 grid. They're nails behind this shotcrete, as well as the drains. There's the drains that run diagonally to drain all the water out from behind the wall. So the main work that's done to hold this wall up is the nails. Those nails are what hold, that anchor the whole wall back to keep the soil in its place. Okay, so this is one of the drilling rigs that we have that does the horizontal drilling. It can either be used as a rotational auger rig, or we can attach percussion to it and down the whole hammer, and we then do drilling into rock. As it's set up at the moment, it's got augers on it. We're drilling into soft sand. The process at the moment is they're setting the angle. So these holes have to be at a very specific angle for their design. So he has a template on top of the mast with a level, and he then sets that level of that mast so that we get it correct to drill. Okay, so once the rig's been leveled, the mast's been leveled, they then start drilling the hole. As I say, it's a rotational auger rig, and they'll just simply auger that hole out. Depending on the length that we've got to go, we can join augers on these machines, and we can get up to 18 meters deep holes with these rigs. This one at the moment is not that deep, so we won't be joining, but this is now the process of drilling those holes to install those anchors. Okay, that's the drilling process. He's most of the way into the hole now. As soon as he's finished, got to his depth, he'll clean the hole out, and then that hole will be grouted. Okay, so this is our BG18, another Bauer piling rig. He's busy, he's set up in Cfa mode to do Cfa piles. The ground conditions are not that great, and we have to do Cfa piles here. It's a bayhead area,
And this is basically a big logistics container depot that we're working with. This is against Sydney Road, and the property this side had a batter on it against Sydney Road, and we're now putting in a contiguous wall, lateral support system, to basically optimize the usable area of the site. So the whole area here that wouldn't have been used is now going to be opened up to a vertical wall all the way along Sydney Road, just to get extra capacity on the land. Okay, there he goes. We're going up here between 7.5 and 9 meters. So we're going into rock. The rock's very shallow here, and then we're creating a socket into the rock to give it the embedment so that it can work in bending. So on this end, this is the very shallow end, there's not a very big retained height here. So here it ranges between 7.5 and 9 meters. Your rotation pressure of the pumps, it indicates it on the computer. So if you start hitting a lot of resistance, the pressures go up and you can see that you're hitting a lot of resistance. And then also your penetration speed. The pumps that are crowding the machine down, when that pressure goes up, you know you've hit resistance, and the speed of penetration will start slowing down. So he watches that in the machine as he goes. The machine then also stores that, and you can get a printout to show what happened on each pile. And you can see whether you've picked up the right resistance and if the pressure's at the right pressure to make sure the pile's been installed correctly. Okay, so that's called a Cfa Extension. This type of drilling rig has that on it to go deep. So what he's done is he's drilled down to a certain depth now that the auger is complete, or the extension has come to the bottom. He unlocks it, sends his drilling head up to the top, and he re-engages it at the top of the extension, and then he starts drilling again, and then goes deeper down. So that's how he gets to the depth that he needs to get to. So that's our grouting plant. The grout gets delivered into this hopper. That just stirs it up, and then the hopper transfers the grout into the stirrer. That's basically a big container that holds the grout and agitates it. It just keeps agitating it to keep it alive. From there, on the other side of the plant, there's the pump. That pump pumps the grout through the hose, and as you'll see, goes all the way up to the top of the rig, goes through the top of the drilling head and goes down the auger and comes out at the bottom of the auger, at the bottom of the hole. When he gets to the bottom of the hole and he's at the right depth, start pumping, the flap at the bottom opens, and we pump grout under pressure into the ground, and then extract the auger, and we leave a column of grout behind, and then we put the cage into the grout, and that's how we then form a CFA pile in bad ground conditions. You can see he's now grinding into the rock already. That penetration has slowed down a lot, and you can hear the machine now starts working hard. Yeah, he's created the sockets over 1 meter already, so, and he's sitting over 8 meters deep. It needs to be a minimum of 7.5. So he's happy with where the pile's now sitting. So now they'll start the process of grouting. You'll see when that grout hose shakes like that, that's the pressure of the grout getting pumped through it as it goes like that. So the guys, they judge it on the machine and his extraction rate and how far he extracts on his computer. It shows how much is coming out, and they count the pulses from the grout pump to confirm that they're getting the right volume of grout into the hole. The grout, it builds up and pushes up so that you keep the positive pressure inside that hole so you don't get any collapse. So as long as you get that grout coming ahead of the end, the shaft should be fine. So this is the reinforcing cage that goes into the pile. It's high tensile steel. It's prefabricated into the right size with the right bar diameters on it. Once we've created the pile and we've extracted and we've left the grout shaft behind, this cage is then inserted and it's dropped into the grout. The grout's fluid, and that cage is dropped into the grout all the way down to the right level. This reinforcing gives this pile the strength in bending. So concrete doesn't have a tensile strength, or very much tensile strength, and this gives it the tensile strength. So this is part of the design to make this work. Okay, this is our RG22. This is the first Dawa rig that we brought into South Africa, and it's a very unique machine. There's only one of its kind in South Africa at the moment. It's a very, very long mast. So the RG22, the indication of his length of his mast, which is 22 meters. This rig I can install, or we can install CFA piles to 21 meters without changing augers or without adding anything on. Very big machine, weighs over 70 tons. Okay, just from behind the machine you can see these tracks are very wide at the moment because of the height of his mast. What we do is when we need to load the machine up and move it, those tracks close in so that he can fit on an abnormal load bed. So those slide in, the mast, 22 meter long mast, folds down. Once it's down, it folds itself over so that it's not too long. So it's not an extraordinary abnormal load. It can go on a standard load bed, an abnormal load bed, and be carted from site to site. And he erects himself. We don't need another crane to help erect. He erects himself totally on his own. Okay, this site is predominantly Berea Reds. The Berea Red has a high clay content, and what that does is it allows the hole to stand open when we're drilling the hole. So we have an open auger pile. We drill the pile, clean the pile out, and then we cast concrete afterwards. You put the reinforcing cage in and then you cast the pile. As you see there, that's where the guys cast the pile. Okay, so the process of creating a basement. As you see, where I'm standing here now on basically natural ground, we'd create an area for our piling rig to come in and start installing the piles around the perimeter. So we'll move this material out of the way, create a little bit of a working area. We'll install contiguous piles all the way around the perimeter. Once those piles are installed, we follow through with a capping beam. A capping beam, as you can see, on top of those piles. That capping beam then follows the row of the piles on top. We construct the capping beam all the way around till that's complete. Once that's done, our piling rig moves off. We bring excavators in, and the excavators will then start removing this material. We'll start digging this down, and as we excavate in layers, and when we get down to the first drop, which is about 2.5 meters down, we then come and install the anchors. So the drilling rig will come in. First the coring will come and we'll core holes through the piles. Once the holes are cored, the drilling rig comes. He installs all the anchors through the piles at that first drop, and we shoot all the gaps between the piles with shotcrete or gun out, and we close that up. Once that's done, the excavators are back. They excavate another level, another 2.5 meters. We will install another row of anchors again. First core through the piles, install the anchors, do all the shotcrete. Once that's done, we'll drop it again, and that's a process that will continue until we hit the bottom, which is around 15 meters in this basement. It's a very deep basement. So this is the start of the process of creating the basement. The piles have been installed and the capping beams been installed. We've put one row of anchors in already. Sorry, 2 rows. The second row, you can see it is at the bottom. The second row has gone in, and the area there where the machine's working will come through and follow through underneath us to the other side of the property, which will create one very, very big deep basement on this side of about 15 meters deep. At the end, you'll just see a really big hole with these vertical walls around you. We then bring the piling rig back again, and then he will install the building piles for the structure that's going to be built. He'll install all the building piles and leave. The main contractor then comes in, trims the piles off, and he puts his pile caps and the columns start in that basement on top of our piles, and then the whole structure basically grows out of that hole up to as many falls floors as they're going to be building. And our piles support the building, and our lateral support will keep that hole open to have the basements. There's usually 3 or 4 levels of basement parking these days. So that's the process of how we create our part of the work before the building comes up out of the ground. So this is the construction site once we finished piling in the basement area. Under each of the columns, you'll see there's a pile cap and then a column. Under each of those pile caps, we've got 4 750mm diameter piles. Each of these piles is installed to approximately 19 to 20 meters below ground to pick up all the column positions. Because of the high loading of the building, it needs to resist that loading. So it's very, very big diameter piles and 4 per column. There's also multiple columns underneath the core and the lift shaft areas that you see there, ranging from 12 piles to I think about 16 or 18 piles under each of those parts of the structure. I'd just like to say thank you for visiting Megapile and coming to spend a day with us, seeing what we do. Thank you.